Okay, so we're back to our playgrounds now, and we're going to take a brief couple of videos out from making apps to look at loops, which are one of the fundamental programming constructs like if statements. Loops allow you to do something several times. So going back to our Facebook metaphor again, if we wanted to display someone's recent posts, we might want to loop through all of their posts and then run the code that will display each of them individually. So really, it's a time-saving device. It allows us to avoid writing code lots of times. We can write it just once and then run that code lots of times for slightly different posts or users or whatever it might be. So loops are absolutely essential to coding, very important if you haven't covered them before. It should become a little bit clearer when we do an example. So there are two types of loops, and in this video we're going to look at for loops, and they work like this. We use the command for to define our loops, and then we define a variable which is going to be the counter variable for our loop. So I'm going to define the variable I, which is kind of standard for a counter variable, but you can put anything you like there. And I'm going to initially set I to 1. So this is slightly strange. We've got a for command and then a var command right next to each other, but that's okay. That's how the whole thing fits together. So we're saying start off I to be 1, and then we're going to keep running this loop as long as I is less than 10. And I'll put some spaces in there. So this is our rule for what happens at the beginning of the loop, I is equal to 1. This is our rule for how long the loop keeps going, so I is less than 10. And then we're going to have our rule for what happens each step. And I'm going to write I is equal to I plus 1. And if you think about it, what this does is it takes I and then adds 1 to it. So this essentially means each step of the loop add 1 to I. So what's going to happen is I is going to start off at 1 and it's going to go up and up and up until it gets to 9. It won't actually make it to 10 because this only works as long as I is actually less than 10. Okay, if that was a little bit strange, then don't worry, all will become clear as we go on. So for now, we'll just display I in the logs there. Now over here, what you now get is 9 times, which isn't particularly useful in itself. It shows that this is happening 9 times, so there's clearly some kind of loop going on, but it doesn't show us the output. So what we can do is click on the little plus symbol there, and that will give us the timeline, which is a bit more detail. Essentially, what we're interested in is the console output, and you can see there what we've got: 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to leave that open so we can see everything going at once. So I'm just going to recap what's happened there. We've started off by defining our variable I, starting it at 1, and then we've said that we want to keep running this loop as long as I is less than 10, and each go of the loop we want to add 1 to I, so it just goes up by 1 each time. So how would we change this if we wanted to say increase I by 2 each time? Give it a go, see if you can change the loop. I hope you managed it. It's just a matter of changing the 1 to a 2. And then we should find that we get 1, 3, 7, and 9, because we keep going in as long as I is less than 10. Obviously, we can change that to a 3. And let's say we wanted to start I at 2. That's simple enough as well. 2, 5, 8. So have a quick mess around with that. It's actually worth pausing the video and just setting yourself a couple of mini challenges. So something like, if you want to display the numbers 3, 5, and 7, how would you do that? There's a quick one for you. 3, 5, and 7. Okay, easy enough. So let's start at 3. 3, 5, and 7 goes up by 2 every time. And we'd want to stop as long as I was less than 8. So there we go, 3, 5, 7. There are other ways to do it, of course, as well. Okay, so that's the basic for loop. Let's just play around with a couple of other things. We don't have to always increase I. We could start off with I being 30, keep going as long as I was greater than 8, and then decrease I by 2 every time. So we can go backwards. So 30, 28, 26, 24, etc. all the way down to, I should say, 10. So that works absolutely fine. We can keep going as long as I is greater than or equal to 8. That's fine, and that will just go one step further. So that might make more sense, actually, to set your loop to be greater than or equal to something rather than just greater than. We can even do things like divide I by 2 every time. So it starts off at 30, then goes down to 15, and then it would be 7.5, etc. I've never actually used a loop like that in a real program, but it can be done. Something else I want to show you is a nice shorthand for this I equals I over 2. The thing that we almost always want to do is add 1 to I each time. That's by far the most common use. So if we just go back to what we had to start with, and we had I is I plus 1. Be careful, by the way, of infinite loops. You can see my computer's not very happy with this because as I was typing, there was an infinite loop because we had I equals I, so I wasn't actually changing at all. So that's not too bad in the playgrounds because Xcode will catch up and fix itself, but it is pretty bad if you get an infinite loop in your app because your app will essentially crash. It will never complete. So do be careful and make sure you define your loops carefully and they never will run forever. So as I've mentioned before, programmers are very lazy and they like to write as little code as possible. And because this I equals I plus 1 is used so much, there's a very nice shorthand for it, and that is I plus plus. So whenever you see I plus plus or X plus plus, that just has the effect of adding 1 to the variable. So that's the same as what we had here. And you can use I minus minus as well to decrease. So quick challenge for you. I'm going to take away the code completely and see if you can write from scratch the code which will write out all of the multiples of 5 up until 50. So 5, 10, 15, 20, etc. Go for it. Okay, I hope you did it. It's pretty straightforward. We start by defining our variable I, and we'll set it to 5 initially. And we want to keep going as long as I is less than or equal to 50. You could have had I is less than 51 or something there, but I think less than or equal to 50 kind of makes sense. 51 feels a bit weird to put 51 or 52, even though it'll work. I prefer less than or equal to in this context. And then each time we want to add 5 to I. There we go, and then just print I to the logs. Fantastic. So hopefully you had something similar to that. You could have had something fancier. Some of you may have done something like this. How could you now change this code in a very simple way to give the output that we wanted? All you need to do is multiply I by 5 when you're displaying it to the logs. So if you did that, well done. That's a bit of innovative thinking, and you can that's a perfectly good way to solve the problem. Okay, one very useful use of for loops is to loop through arrays. So I'm just going to show you how to do that now. In fact, can you define an array with any 4 numbers in it? It doesn't matter. So define an array with 4 numbers in. All right, hope you did that. So I'm just going to do something like, there we go. So there's our array, and then square brackets define our array, and our array is 6, 3, 8, and 1. So if we want to loop through that array with our for loop, as we quite often want to do. This is a genuinely useful programming tool, as I've used the example many times now. Facebook, going through the posts, or Twitter, going through the tweets, or whatever it might be, going through all the users and finding the ones within a certain distance of your current user, whatever it is you might want to be doing, running through an array is very, very useful. So the way we do that is for, and then let's say X. You can choose any variable name there you like, in array, and then let's just display X, and that should make it fairly clear what's going on. So what's happening here is we're looping through array, or looping through ARR, and each time we run through it, X is given the value of that item in the array. So if we look at it here, we've got 6, 3, 8, and 1. So that's a really useful tool, and definitely something I use a lot, looping through an array and then doing something with all of the contents. Now that's all well and good. What if you wanted to, let's say, add 1 to all of the values in the array? Now what you might think is that you can do something like X equals X plus 1. But unfortunately not, because remember, X has just been set to the value in the array. It's not actually that object. So if I add 1 to X, in fact it won't let me, because X is an unchangeable variable. It's immutable, as we say. But even if I could, that wouldn't change the first value of the array, because X is just something that equals that object there. It's not actually that object. So if we want to do something like that, I'm just going to undo that to get rid of the error. We need to use another function. It's very similar. It's another for loop, but this time we write things slightly differently. And so instead of just getting X, we get the index and X. So the index is the number, remember, starts at 0, so 0, 1, 2, 3, and X is the value. And this will enable us to actually control the array in some way. And then we use the keyword enumerate. And we're going to enumerate array. So this essentially does the same as what we had up here, but it gives us the index as well. So let's just quickly convince ourselves what that index is. It should, of course, be 0, 1, 2, 3. And there it is. 0, 1, 2, 3. So, can you think then, if we wanted to add 1 to each value in this array, how would we do it using this? Give it a go. Hope you got it. All we need to do is say array, ARR, and then index, because that's the one that we're dealing with at any given time, is equal to X, which is the value, plus 1. That's it. So that obviously doesn't print anything out. But if we then display the array, we get 7492. So everything has been added 1 to. Okay, so just to run through that again, for loops we can use to have an initial value for our counter variable, which we normally call I, and then keep the loop going as long as a certain condition is met, and then set an instruction for each step. We can also use for loops to loop through arrays, which is extremely useful. If you just want to look at what the value is, then this instruction is definitely the simplest. If you want to actually change the array in any way, then you'll need to use the enumerate function. Okay, so quick challenge for you. Opportunity to use the enumerate function. All you need to do is create an array with 4 numbers and then create a command which will halve every value in that array. Good luck. All right, how did that go? Should have been fairly straightforward, I think. So I'll use my standard array, and we'll go for numbers like that. And then we just need, so index, and this time I'm going to use value just to make it slightly clearer what this thing is. It's the value of the array, and we want to enumerate our array, and then we just want to set array, sorry, ARR, index, and I'm going to change it slightly from the way that I did it before, just to show you another way, divided by 2. So I could of course use value there, and it might be slightly neater to do so, but I can just as well use array index because that's the same value that I want. And then just to check, let's display the value of the array, and we've got 4303. Did you anticipate that? Did you think about what might happen to these odd numbers? They're defined as integers, so when we halve them, they will round, and indeed round down. So 9 goes down to 4.5, which then rounds down to 4. If I wanted to make those exact, I could do something like change the initial definition to put point zeros at the end, and that will force Swift to create these as floats or doubles, and then when it halves, obviously the value is then kept intact. So bear in mind just another little potential issue with ints there, that if it's created as an int, it will remain as an int. So if you try and halve it, it will round down. Okay, I hope that all made sense, and you've now got a fairly good idea what a for loop is and what you can use it for. And in the next video, we'll go on and look at another type of loops, the while loop. See you there.